So Darren, look, thanks so much for coming in today. We've talked and been on a similar journey for many years. It's great to take this time to sort of sit back and reflect a little bit on what we've learned. But everyone knows a little bit about me, but for yourself. So you're a chemical engineer at the University of Queensland, successful researcher. How did you become a chemical engineer researcher at UQ?
Yeah, well, believe it or not, I'm trained as a scientist. So my base degree was in applied science in material science. But I would consider myself a material scientist / engineer. Early work was biomedical device focused out of one of the big CRC for cardiac technologies in Sydney. And then my wife fell pregnant and we were not going to bring up a family in Sydney, so moved to sunny Queensland in about 1999, landed a job in chemical engineering, and I've been there ever since. So we're coming up to 25 years.
Wow.
Love working with chemical engineers. They're great at scale up, they're great at processing, they're great at inputs and outputs and unit operations. If you marry that up with materials, it's a pretty powerful marriage, and that's why I'm still there.
Yeah, awesome. Yeah. You sound like you're still loving it, which is great.
Yeah.
So I know you were involved in a startup called Tenacitech, almost about at the same time, paralleling with my journey with Progel and Perky.
Yeah.
So that was quite a long time ago, and that sort of the intensity of that's finished quite a while ago. So can you give us a little brief potted history of Tenacitech, and what you learned about yourself and about the process of taking an idea and turning it into something that actually would have an impact in the world?
Sure. Well, it was 20 years, Cameron, from start to finish. If you include arriving at UQ, I was very fortunate. I came from a fairly successful biomedical device program.
Yep.
And I didn't know I was surrounded by such great people who taught me a lot of things about translation, but I was. And so when I arrived at UQ, I was looking to do that again. Nanotechnology was coming up. I had made a definite decision that I wanted to do something surrounding nanotechnology. And initially the concept was doing something with the elastomeric biomedical materials and adding nanotechnology to that to make something better. So I'd come from biomedical, and we always work with things that are more comfortable. That's where we started off. So for example, we were thinking we could make the world's strongest condom, or something along those lines. And that was actually, that appeared in the early pitch. So fast track to about 2005, we actually had enough data in the lab. I'd built a team, and we were able to get an IP lodged, provisional patent lodged, and by 2007, we got some seed funding from UniSeed. So it took 7 years from arriving at a new university, building a team, having a few PhD students and a postdoc running around, to having enough data to get $500,000 pre-seed investment. Now, UniSeed followed up with us in 2007, 2009, 2011, and then eventually in 2014, Brisbane and Melbourne Angels threw in some money as well. So we, the whole journey, I think we were invested to the tune of about $6.5 million. I'd brought in nearly $5 million of research funding on top of that. If we look at the outputs, graduated 14 PhD students along that journey who were at least fully or partially linked to the technology platform. Dozens of research papers, lots of book chapters, and a hell of a lot of experience.
Yep.
So in that 20-year time frame. Very tortuous path, going from initially thinking about medical. Basically the technologies, these little nanoplates with special surface chemistry that you put a tiny amount into a stretchy material, or a hard transparent material as it turned out, to make it more durable, to make it stronger, tougher, more scratch resistant, wear resistant. And our technology actually did that better than anyone else in the world. If you just looked at the nanotechnology solution, something I'm still very proud of, it worked.
Yeah.
Just the fact that it worked, and it worked better than anything else, doesn't guarantee that it will be a commercial success. And I guess just to finish off, the company did sell, so it is out in products, it is being sold, but it sold for a number much less than the money that was poured into it. And to this day, I don't really know what that was, and it doesn't matter. In terms of technical success, I suppose you could say we succeeded. Our nanotechnology is out in the marketplace. in automobiles and that sort of thing. In terms of blockbuster history, no, it wasn't that.
Yeah.
It was still a good thing.
So you've had an idea, and I like how, in some senses, you had an experience with a what, the biomedical, and then you encountered a how, the nanotechnologies, and you're trying to find a new what to do with that.
Yes.
For a who and a why, I guess, trying to find the reason.
Yes, that's right.
So, I talk a lot about who and what and why and how, and it doesn't really matter where you start. You just got to start somewhere, but you also got to ultimately end with humans who actually care.
Yep.
And that's the hard part.
Yep.
You can make things that work. And this was my experience in Progel and Perky. We did a lot of things that worked, but it found it really hard to get people to care. And obviously, and that's the challenge, I guess, as a researcher. Your job is to work out how to translate the how into a what.
Yep.
But obviously, then the real hard work is actually unlocking value from that. And creating value with that. So I mean, I think it's a tremendous journey to actually have got from that point right through to having impact and having products in the marketplace. But tell us a little bit about because you've invented a lot of things. You're a researcher. Like, you spend a lot of your time thinking about things and then trying to reduce them to practice, making them real. And I know you're still involved. I think you've got an active project now where you're trying to create a real impact in the environment sector. Can you give us a flavour as to why you keep doing this when it's so hard? Like, this was a 20-year journey. And sort of somewhat rewarding in terms of technologies out in the marketplace, but not as commercial success. What's the motivation behind why you keep doing what you're doing? Why aren't you just a researcher who's just publishing and doing research? And there seems to be something about you that wants to do something else.
In a nutshell, I think there are lots of academics that have very large brains that do lots of things at once. Lots and lots of things, or too many things. And I'm not that. For whatever reason, I like hanging around in the technology space for a decade or even two sometimes, building a team in that space. And as part of that journey, having conversations with people outside the university and learning about how to make things better. I mean, materials people, what we do is we break things. We break building blocks of products, and we try to figure out why they broke, and we try to figure out how to make them better, more sustainable, more durable, whatever it might be. And you can't do that without talking to people outside the university. We're pretty smart, but we're not that smart. We need that feedback loop. And so I guess for me, it's about the feedback loop. It's really important.
Yeah, great. And maybe that takes me on to my next question, which is you've learned the value of talking to humans, and actually really understanding maybe solving the right problem, or what the challenges are, or so if on that 20-year Tenacitech journey, if you knew then what you know now about what you learned through that process, how would you have gone about that differently? What would have been some of the changes you might have made?
There's a lens to look through on all of that 20-year thing. And one thing we don't talk about sometimes is that there were many humans, many companies, many small companies we talked to who had that pain and really needed what we had invented. There was no shortage of people who were motivated to use it. But when you put a business lens on that, and particularly an investor lens, investors want their 10-bagger or their 100-bagger, and the market we were looking at was very fragmented. So a lot of these opportunities were overlooked. Now, in hindsight, if we'd explored just a few of those and they'd worked, we would have been in a better position than we ended up in. And I guess the tension for me as the inventor, the entrepreneur, was to see some of those conversations shut down as we moved along was quite hard. Yeah, because you form relationships, you have good conversations, you see the spark in people's eyes, and some of those opportunities didn't go forward. And in hindsight, maybe if we'd started small and converted a few of those, we could have built a business, even though the opportunities were a few $100,000 a year, not X million dollars a year of revenue, I think we still could have built a business that way. But investors are impatient, and there's only so much money that you can burn through. So I understand the tension, but there was a lot of that in the guts of the 20-year story.
Yeah, look, that's so fascinating for me, because I think because we're talking about innovation, really, we're talking about transformation.
Yeah.
And all of the evidence says that it's hard, and it almost always starts small.
Yep.
When it starts big, it very rarely is successful. Look at the Iridium satellite phone. I mean, they launched, with a $5 or $6 billion program, satellites, and it just failed.
Yeah.
And so the best innovations, start small and they actually grow incrementally. And so it's interesting, this tension.
Yeah.
That when you're trying to apply a large company mindset to innovation, to doing something new, that observation you made is you had lots of people that you talked to that actually really had real problems.
Yep.
And they really needed a solution, and you had the solution. But the business model didn't sort of fit that. And so what I'm hearing from you is that the business model was that you're trying to apply the business model lens, which is we've got to have a big customer, we've got to have a big opportunity, so we can actually make a lot of money. Actually didn't work. And what you've said is that you like these small opportunities which might have been niche and not valuable in their own. But you would have learned through that process, made a difference, and then learned through that and changed the technology, as you had to do anyway.
As I said, we started in medical. You may recall in the early noughties, nanotechnology was grey goo and scary stuff, and I actually remember doing some media interviews on that, which I had to be very careful what I said. So that ended up being what turned us away from medical, the unknown of putting nanomaterials embedded in materials inside the body. Then we moved to industrial elastomers, and the market turned out was too fragmented. So opportunities weren't big enough within that, what was a $14 billion market, including a couple of years working with one of the biggest golf ball manufacturers on the planet, and ticked all the boxes, delivered on everything technically for that project. And then at the last minute, they decided to change their design of the golf ball and halve the thickness of the cover that we were trying to make more durable for that product. And we decided not to continue with that one. But let me just open a window into that opportunity. We had supply chain with Kobo, Akzo Nobel, all of the nano building blocks. We did trials in Lyon in France at a small pilot partner, set up performance. We did bigger trials in Pittsburgh at Bayer Materials Science. So we made these materials at several hundred kilo scale. We injection molded golf balls. We tested them. They ticked every single box that, as a technical manager, we were asked to do. Still didn't go forward. But there was a weekend there where my team turned themselves inside out. And I guess this is, looking back, this makes me happy because as a leader of people, when they step up and they've got very little time and resources to solve a problem like that in multiple countries with multiple stakeholders, all coming together on one weekend to make a whole bunch of materials, it's really difficult. And we did it. And I'm still very proud, and I'm sure they are proud. Celine Chalier, Grant Edwards, there's a whole bunch of people who remember those times. So, I mean, the investors won't remember it, but we remember it.
And I think it's such an interesting insight, and again, with my Progel journey, we spent a similar amount of time, nearly 20 years from the invention, and we talked to hundreds of companies similar to you, the list of companies we talked to, and they all had real problems that we knew we could solve, and we did solve. But they didn't go ahead for a whole heap of different reasons, And one of those reasons is this sort of risk appetite, that obviously the investors have their own risk sort of appetite, and they want a very big reward because they've taken a risk on investing some money, and so they don't like the idea of small rewards because they're not sure that that's actually going to reward them for their risk. But then the companies you're talking to also have a risk aversion in some ways, and they don't want to do something unless there's just no risk there. And we're doing something new, then there's always risk,
I always say in materials, there's nowhere to hide. You have to make stuff. It gets tested independently by someone or an independent lab or a company There's nowhere to hide. There is absolutely nowhere to hide. So you have to make it better, and it's not easy.
Yeah. But I think that what's interesting is that there's a number of different elements of risk. There's technical risk, and that's what you're talking about. Is it's sort of almost binary. It either works or it doesn't work. It does what you say it's going to do, or it doesn't. But you've exceeded that. You delivered on everything in terms of the technical risk. So you reduced the technical risk, but there was obviously commercial risk or scalability risk or market risk, all these other risks. It was outside your remit. That wasn't your job to try and reduce those risks.
I remember one thing very clearly. We're in Vancouver and we pitched to probably one of the best venture capital investors, Pangea Ventures in Canada. And Pernesh Sanjiapal's written textbooks on this stuff. And he had a look and he said, "You've done amazing work. It works. It's amazing. I'm worried about one thing, your supply chain management. You don't own all your little building blocks and all those chemistries. What happens if your suppliers go out of business or change hands?" He was right. He was absolutely right. And he was so clear in the way he delivered that. And there was nothing I could do about that.
Yeah.
So at the end of the day, that was probably the thing that spooked, people on the other side.
Yeah, and so I think it's that, and that's a business model sort of understanding, isn't it? So what's the right business model? Because the technology is just one element of that. You've got a really complex business model. I know you teach business model innovation at university, and so and so I guess I want to sort of drill down a little bit to what do you think are the most critical personal skills and characteristics that an innovator, an entrepreneur, or a game changer needs to, one, be successful, and to two, to just survive, because it's a long, hard journey.
I think on a personal level, you need to be a bit of a Pied Piper. You need that spring in the step. You need to be able to motivate people. You need to be very straight and honest with people, because I've had that experience. If you take care of people, they'll go to the moon and back for you. And there's a whole bunch of people who've worked for me who are out doing amazing things now who are exactly that. If you look after people, they will grow an extra leg and deliver. So that's one of the great things about it. I think you have to be tenacious and focused. If you have too many disparate things going on, you're not going to leave room for what's coming, because what's coming is always bigger than you think. And I'm pretty good at that. I tend to just shut down a lot of other opportunities and go, no, this is good. I'll dedicate myself to this for a very long time and I can live with the consequences, but I'm happy in this sandpit. And that, for us, getting into the technology space so early, it's going to be more than a decade. So I know I've done 4 of these now. I might have room for one more. I'm 54 in October. So that's just, you have to be focused, tenacious, and disciplined, I think.
And I know you're working on another project now that is really exciting from an environmental point of view. I'm not sure how much of that you can talk to us about, but I know we've talked about that. I'd love to know a little bit more about that.
I guess in recent decades, we've, for whatever reason, ended up working with biomass and circularity. And we've come up with a way, without using water, to turn agricultural residues, crop trash, into a water-holding, nutrient-rich gel. It sounds funny to say the word gel and be able to do it without water, but our learnings over the last 20 years is that as soon as you add water, a tonne per cubic metre, the logistics of moving things around farms with diesel prices and everything, it kills you. So I'm really excited about this one. So potentially it could be something that you help farmers deal with climate variation. We're talking about big crops, wheat, for example. It's an $18 billion export market for Australia. And on this one, we do have control of our supply chain.
Okay.
And it's very simple.
Cool. That sounds exciting.
Yeah.
And so I know you've just finished a program with some collaborators in the US, but how would you contrast how you're doing this opportunity compared to how you were working 20 years ago? What different role are you playing? Big
contrast. If I think back to Darren, the Chief Scientific Officer, hopping on a plane with the CEO, who was an accountant, wasn't an engineer. Hopping on a plane and doing our customer discovery. I mean, and it wasn't that luxurious, flying to the US, hopping in a hire car, staying in really cheap hotels, driving from state to state, doing our homework on the whatever company we were visiting, turning up, having those conversations. What an expensive way to do customer discovery, human-centered design. But that's how we did it. And some things would move forward and some things wouldn't. We were burning a lot of money doing that. Yeah. Wouldn't it have been better to get some help, do some homework on all of that stuff in a less expensive way and save that money for the technical team? And we could have used more dollars and more people, absolutely. If you contrast that to the 275 interviews we did as part of the NSF Convergence Accelerator, we're probably ahead of where we were before even spending one investor's dollar. So, and I'm holding back. I don't want to ask investors for money until we've proven this up. So I think you can get the story.
Yeah, wow, 275 conversations. That's phenomenal. I mean, and I'm assuming you've learned inextricably more in that process without actually spending money than what you did previously.
We just got 830,000 from CSIRO yesterday, signed off. It will employ the postdoc HEMA for 3 years, and we haven't had to ask an investor for money. So we've got 3 years of funding to move the thing forward. Really good.
And has that helped you get more clarity or insight around the problem that you need to solve and the size or the direction of the opportunity?
It has. And even academically, who the experts that we need to collaborate with before we generate that data that will produce a compelling business case for the first investment, whatever that ends up being. So now we're working with soil physicists, because it all happens in the soil. You've got to measure all these things. So that's what we're doing right now in the lab. I didn't know that. Yeah. I don't know anything about soil.
Yeah, awesome. So just finally, I'd love you just to take a moment to reflect on, what does all this mean about how you've integrated, obviously a real curiosity around the science, around how things work, with actually trying to translate that science out into impact, out of doing things in the world. How do you see that sort of your own sense interacts with your own sense of self or meaning or purpose? Like what are you hoping to look back on and say, well, look, I'm really proud of that, and this is why I think I'm here?
I now sort of write about my academic life in terms of major works. So I actually think of these translational and scientific decade-plus chunks as major works. Yep. If you've been reading the papers lately, you'll see that, academia in Australia and in fact the world over is a pretty fragile sector. It's a big export market for the education that we provide, but it's also quite fragile in terms of funding. For me, doing these major works, engaging with people outside the university, more than half of my funding comes from industry or investment. More than half of my graduates, my PhD students, work in industry. It's been nothing but good. And so for me, it's just my best self gets involved in these things. As an academic, that's the best way for me to function, because in some ways my brain isn't big enough to do 20 disparate things and understand all of them. You got to know yourself to be able to make good decisions about what you throw yourself into. Don't know if that answers your question.
Yeah, no, that's great. And I think what I love about working with scientists and researchers is this desire this curiosity to understand how things work, but this desire to do something with that and not just hold it. Whether it's publishing is one mechanism, but you seem to have found a few different other mechanisms to try and translate what you've discovered, these works that you've created, but you want other people to see them. So you've sort of working really hard. Now you're in the fourth sort of iteration of a startup or of a translation project, because you want to translate that and make that available to solve some of the world's biggest problems.
Yeah, like materials is a very tactile discipline, and you have to do that. As I said, we make it, we figure out why it broke, and we try and make it better. Well, without throwing your materials to people outside to break them, you're not really doing your job.
Yeah, that's great. That's a great way to finish. Thanks for your time, Darren.
Thanks, Cameron.
Great.